How to solve a simultaneous equation using matrix method. It's Kisembo Academy, and thanks for tuning in. There are very many other ways of solving simultaneous equations. We can solve simultaneous equations using elimination method, we can use substitution method, we can use graphical method, but this tutorial will concentrate on just one of the methods, and that is the matrix method of solving simultaneous equations. We'll illustrate using an example. We have these two simultaneous equations, 2x plus 3y is equal to 4, and also we have x plus 2y is equal to 3. These are two simultaneous equations that require to be solved using matrix method. So to begin it off with, we need to first of all extract the matrix we are going to deal with. And we extract this matrix by just extracting the coefficients of the unknowns. The coefficient of x here is 2, so we extract 2. The coefficient of y here is 3, so we get the 3. The coefficient of x here is 1, so it is the 1 there. And then the coefficient of y here is 2, and that's the 2. So we end up with our matrix as 2, 3, 1, 2. So this is the matrix. We multiply this matrix by the unknowns. The unknowns in this case here is x and y. So we follow that order, x and y, because the first term here is x and the next is y. Now if it is the reverse, if it was 2y plus 3x, or if it was y plus 2x, then it means that the order of our unknowns here would be y and x. The order of this matrix, the way we present them, is dependent on which comes first here. Here it is x that comes first, so it is x coming here first, then y comes next, so y next. So this matrix multiplied by xy is supposed to give us 4, 3, and that is the 4, 3. So now we are going to deal with this to find the value of x and y. So for us to be able to find the value of x and y, it means that we need to eliminate this matrix from this side so that it goes this way. We need to remain only with the unknowns here. So now for us to be able to eliminate this matrix, it means that we're supposed to multiply it by its inverse. When we multiply this matrix here by its inverse, it means that we are going to remain with nothing here, or we are going to remain with an identity matrix here, so that we're able to remain with x and y on only this side and the rest is the other side. So it means that we are going to find the inverse of this matrix. When we get the inverse of this matrix, we multiply it on both sides. We multiply it on this side and that side, and then afterwards we'll progress and we'll remain with xy on just one side of the equation. So we begin by finding the inverse of this matrix. In our previous videos, we explored in detail on how to find the inverse of the matrix. So we all know that finding the inverse of the matrix is equal to 1 over determinant times the adjoint. So we first get the determinant of this matrix by saying the major diagonal, which is 2 times 2, minus the minor diagonal, which is 3 times 1, to get our determinant as 1. After getting our determinant as 1, we find the adjoint of this matrix. The adjoint of this matrix we get by interchanging the numbers in the main diagonal, which is 2, with the 2's interchange. Then in the minor diagonal, we simply multiply the numbers by negative 1. 1 times negative 1 is negative 1. 3 times negative 1 is negative 3. So after getting the determinant of the matrix and the adjoint of the matrix, then we can substitute it in here so that we are able to get the inverse of the matrix. And it is this inverse that we are going to multiply here on both sides. And this is what is happening in our next step. In our next step, we are going to multiply the inverse of the matrix, which is 1 over determinant times adjoint, times the original matrix, which is that one, this one, times xy, which is that, is equal to 1, the inverse of the matrix, which is 1 over determinant times adjoint, which we are going to multiply, times 4 over 3, which is that, 4 to 3. So it's the substitution going on in the next step. So 1 over determinant is 1 over 1. 1 is the determinant times the adjoint, which is this one, which we already got here, times this, times that, is equal to 1 over determinant, which is 1 over 1, times our adjoint, which we already got as 2, negative 3, negative 1, 2, times 4, 3. Then the rest is math. So we multiply this by that. And when we multiply a matrix by its inverse, we are supposed to get an identity matrix. So as we are multiplying here, you're supposed to make sure that the final answer you're getting is an identity matrix 1 0 0 1. Now if you multiply these two and what you're getting here is not an identity matrix, then it's supposed to show that there is something wrong with your calculation here. So we get that, multiply it here, we do the same on the other side. And so, of course, the multiplication, it's row by column. 2 times 2 plus negative 3 times 1. Then this row times that column to get this. 2 times 3. 2 times 3 plus negative 3 times 2, which is that. Then we have this negative 1 times 2 plus 2 times 1. Then we have negative 1 times 3 plus 2 times 2, which is that. So when we compute all this, we shall end up with the identity matrix times xy. On this side of the equation, it's simply going to be matrix multiplication. This row times that column, then this row times that column. 2 times 4, which is that, plus negative 3 times 3, which is that. Then we have negative 1 times 4, which is that, plus 2 times 3, which is that. And then we compute that and we end up with negative 1 and 2. So now, of course, when we multiply an identity matrix by any matrix, this gives us the same. This times xy gives us xy is equal to negative 1, 2. So it means our value of x is negative 1 and our value of y is positive 2. And so this is how we solve a simultaneous equation using matrix method. We'll do one more example. We have a number 2p minus q is equal to 8, 4p minus 3q is equal to 14. We are required to find the values of p and q in that simultaneous equation. So we are going to extract our matrix by extracting the coefficients of those unknowns. The coefficient of the unknown here is 2, the coefficient here is 4, the coefficient here is negative 1, the coefficient here is negative 3. So it means that our matrix here is going to be negative, it's going to be 2, then that is 4, then this is negative 1, then this is negative 3. Multiply that by the order of the unknowns, it's p coming first, then q. So it's going to be p, q, that is supposed to give us 8, 14. 8 and 14. Then after that, then we go ahead and find the inverse of this matrix. When we get the inverse of this matrix, we multiply it on both sides. So the inverse of this matrix is going to be, first get the determinant of the matrix, which is 2 times negative 3 minus 4 times negative 1. We end up with negative 6 minus negative 4. It's going to give us negative 6 plus 4, giving us negative 2. So this is our determinant. So we go ahead and find the adjoint of this same matrix. So the adjoint is simply going to become, we interchange these numbers in the main diagonal, which is, so here we have negative 3, and this 2 comes down here. Then in this diagonal, we multiply by negative 1. 4 times negative 1 is negative 4. Negative 1 times negative 1 is 1. So we go ahead and, so it means that our inverse, the inverse of the matrix is going to be 1 over determinant, which is negative 2, times the adjoint, which is negative 3, negative 4, 1, and 2. So after getting our inverse, so we are supposed to multiply the inverse on this side of the equation and that side. So bringing this back, it's going to become 2, 4, negative 1, negative 3 times PQ is supposed to be equal to 8, 14. So we are supposed to multiply this inverse on both sides of this. So multiplying that is going to give us negative a half into negative 3, negative 4, 1, 2, times that is supposed to give us 1 over 2, this is negative, into negative 3, 4, 1, 2. Like that. And then the rest is matrix multiplication and we get our answer.